Right, so welcome back. We will start the second session, and over here, we focus on image processing. Okay, so once we got the information, the sensor data, we will see what we can do with the data. Right, next. Next. Okay, so again, so this is the arrangement. So just in case that you want to invite your friend and anyone, so please join us in the Zoom, or you can ask them to go to our Facebook page to see this session. Right, so please invite your friend, colleague, your student to join our session. Right, okay, next. Okay, so just now I show you like we can connect to our USB cam, then we can run the driver, then we able to get all the information in ROS topic, then we can show it in an image form by using the ROS topic image view package, the node image view to show you the color information and also the depth information. Okay, so the next thing that I want to show you is how we want to start do some programming. So the first thing is like we can run a very simple code in order to take the photo, right? Take a photo. So in order to take the photo, it's basically just to grab one of the frame, which is just over there. You actually have a lot of frame of the images throughout a certain interval time. So now I'll show you a way using a Python code how to grab one of the frame and then save it in a file. And that is how we take the photo, okay? Take a photo. How we can save the data into image, okay, to an image, right? Then we also show you over here, we also like to show you two ways of doing this. So the first way is to run a node that just take the photo directly at the instant when you run the node. Okay, so over here you can see our example is inside this RC Home EDU Vision. So it's our Vision package within our example. So inside there's a node, a Python script called takephoto.py. So this code will show you how we can actually do that operation to save one of the frame into an image. But similarly, we also prepare you another version, which is the takephoto_sub.py. So we have the sub, which is subscriber. Okay. So what is that means, or what is the difference between these two? Is the second one with the sub, it have a subscription to a new topic, which is called take photo topic. So you can see over there, the topic is over there, and then it wait for the instruction, which is if you send a take photo or you can change it to other things, once this node receive this message, it will grab the frame from the image raw topic. So this is very handy. Why we do this is just to refresh your development in the first class where you do the publish subscribe. So with this example, you can easily make a robot that wait for a certain instruction before it can start to take a photo. So this is similar, like I can give you an example, which is I always ask my student to do is to develop a selfie robot, but not really a selfie robot, it's a photo taking robot. So just imagine if you are in a party or gathering or anything. So I guess everyone faced this scenario before. You want to take a group photo, so you met a lot of friends and you want to take a group photo. So one of you have to like sacrifice and take the photo for the rest of us, right? For the rest of you, right? But over here, if let's say we can ask the robot to do this, then it will be perfect. So because everyone can fit into the camera, the image, right? Okay, so but you might need some mechanism to ask the robot to take the photo. So you need the timing for you to wait behind the camera, in front of the camera, and then the robot will wait for your signal. For example, like robot, please take photo. Okay, I will take the photo. 1, 2, 3, cheese, and something like that. So in order to wait for that instruction, you can use this take photo sub. So over here, this take photo sub will wait for your instruction. So this instruction can be given in, for example, over here, we demonstrate using a terminal. We publish a message into this take photo topic. But of course, you can replace this with other mechanisms. For example, you can use speech. Okay, you can use speech. So you use speech to like, once you detect certain thing, for example, like take photo or anything, then you can create a note, which is the note that you written last week. You can create a note that it will send information into this take photo topic and then to trigger the event so that this take photo sub will capture that frame at that moment. Okay, so that is how you can extend this code and use it to develop a full application for your robots. Okay, so later on, David will show you how this thing works in actual operation. But over here, two things I need to like remind you. First is like you before you start using this example, you need to specify the correct image topic, which is in the default, it is written for Jupyter Robot, which is using the camera top, which is you don't have this topic if you are using your USB cam. So make sure you replace this line in the code. David will show you how to replace this to USB cam image raw, which is the topic for your sensor. And also you need to remember where the photo will be stored. Okay, it is in the current folder. Right. So I will leave the demonstration to David, and David, please demonstrate what I just said to the audience.
Okay, thank you, Professor Jeffrey. Now I will show you how to use a take photo script, py.py. So first, as Jeffrey have told you, we need to confirm the image topic in the take photo.py file. Where is the take photo? We can find here. Catkin WS, Catkin workspace means SRC, and then RC home IDU learn rows, RC home IDU vision, and we can use finding the scripts take photo.py here, and about the here line 38 we can find we have several topics. We can use this to comment the wrong topic, and we can type the right topic here. Pay attention to the you use the spacebar to get the enough position to type the new codes here. So because we use the USB camera, so we need to change the topic to the USB camera. The USB camera is USB cam image raw. USB cam image raw, and click save. Okay, I will show you the result. First, we need to bring up the camera. We can find the image here, and we open another terminal. We can use this node. Those run vision take photo.py. We can get the message from the terminal that we have saved image in JPEG format, and the name of the image is the time, the date, and the exact time. We can find the picture at the home position. This is a common current photo of the we have saved the image. This is a take photo, and then I will show you the take photo sub. We also need to find the take photo sub.py to make some change. Scripts take photo sub. We also need to change the topic here. And click save. And then I will start another node. And then this node need to wait for the message take photo. So we need to open another terminal, and we use rows topic pub. Rows topic pub. It means one time, just one time, to the topic take photo. Take photo, okay. So please pay attention to the second terminal, and after I press the enter, we can find that it also take another picture. So we can find the name of the picture is different. So we can check there is two. This is the first one, and this is the second one, almost the same, but it's a different name of the image. Okay, Jeffrey, let's take photo. Thank you.
Right, thank you. Right, so let's proceed. So now you we able to capture from the data from the sensor, then we able to save this using a Python script to save this into an image file. So basically, we can do a lot of things with this photo. Okay, so after this, I will show you what are the analysis or the tools that we can use to process this data or these images in order to give us some extra meaning of the environment. Okay, so let's proceed to the next slide. Okay, so we start with the first one. So one very fundamental concept, which is just now, like the images are composed of all the RGB value. So this is the color. So one of the most straightforward analysis we can do is based on this value, which is the color. So one thing that we can use instantly from the OpenCV apps is this what we call the cam shift. And over here we can do object tracking in the sense that we are tracking the color. So we using the color analysis, we do some classification, then we can find a group of similar color, and then we can track this group of this region within the image and do object tracking. Okay, so the concept is the same. I mean, like the workflow is the same. First, you bring up your sensor, then you get all the sensor data in terms of raw image. And over here, if you are using USB cam, so the image equals to USB cam image raw, that is your image topic. So in order to use the OpenCV apps, which is you see, you just one line. Okay, so in ROS, you just ROS launch, and then you specify OpenCV apps, which is the package name. Then you specify the launch file, which is over here is the camshift.launch. But after this, after that dot launch, you need to specify one argument, which is very important because without this argument, you cannot get anything, right? Is the image topic, because you need to put in the image topic into this launch file in order for it to do the processing. Okay, then once it launch, you execute the processing, then you will have some interface that you can select the color that you want or the region that you want. Then it will start to track that area based on the color. Okay, so David will show you this whole thing in operation, and then later on after this, I will show you what you can do with this in a practical application. Right, so David, please proceed with the demonstration.
Okay, now I will show you the cam shift effect, how to segment the color and select the color from the image. First, we need to bring up the, First, we needed to bring up the camera again. So if you see the image here, that means the camera is working well. So minimal the window, and we use another terminal to use OpenCV apps cam shift. So we need to tell the node where the image come from. So we need to tell them the topic name. I type the wrong name. Image row. So that it will automatically start two windows. The first is a camp shift demo, and another is a histogram. Histogram is to show where you select the color. So for this camp shift method, we can see from the, can we enlarge the windows here? We can see from the camp shift demo, we have some information we can find. The first is a 3 bar we named Vmax and Smin. And there is also the position of the mouse arrow. You can see I changed the position of the mouse, and the X and Y will change according to the position of the mouse arrow on the image. And the RGB is the RGB value of the where the mouse arrow point. So this method uses the HSV color space to select the color and track the color area. So I can use the mouse left button, click left button and hold and drag a rectangle, and then I release the button. It will change to track another color in the image. For example, I can track another light blue, dark blue, or maybe the purple. Okay, and almost green, red, and the yellow, So I will show you the explain simply about how the camera shift method tracks the color area in the image. First, I will say something about the color space. I prepare PowerPoint to show you the color space. For example, we can find describe the computer describes the color according to the RGB color space. That means the green R, red, green, blue RGB color space, and it is a cube in the 3D space, and the different color at a different corner of the cube. But this will be very difficult to segment the color if we use RGB space. I will show you why this happened. For example, if I just put my mouse arrow on the yellow area here, and you can find the RGB value is about, for example, the R 100 and almost 130, and the green 130, and the blue almost 30. So I ask my partner to use because it's almost noon here, so the light condition is very bright. So I use an umbrella to cover the up of the table to reduce the light condition, to see what happened if we change the light condition. You can see the RG value, and almost also the blue value is changed to large compared with the original one. So for the red, almost 220. The green is 230, and the blue is 230. After we remove the umbrella, it will be changed to the original value. So this is very sensitive to the light change. So if we use the RGB space to segment the color, it will not okay for the environment. The robot will work. So we use the HSV. We use HSV in this method. HSV means hue, saturation, and the value. This is we can describe the space. I use this hexagonal pyramid model. So the hue means which color, what color is it? Let's make it simple. The hue means what color is it? For example, is the red, yellow, blue, green, cyan, magenta, something like that. And the saturation is how the color looks like. For example, the saturation means from the center of the hexagon, from the center, it's maybe the light red, and to the dark red, or something like that. So we can use this method to segment the color with a low influence from the light change. For example, just as you see, I use an umbrella to cover the light, the circle, the red circle almost not change. So that means the segmented result is stable if we use HSV method. And V means V means the mean value. We can set the bar here, and the V max means the max value of the V value. And the S mean means the low threshold of the saturation. And how can we change the Q value? Just we need to use the method of the left mouse button to click and select the rectangle to select the different value of Q. Okay, if we change the S mean, maybe the circle will be changed to small because we needed to find more dark red or dark blue to satisfy the threshold here. But if we change the bar to lower, that we can get more area of the segmentation result. You can just adjust the value to see what happened. Okay, this is the result of the color segmentation use comp shift. And there is also another way to describe the color space we call YCBCR, or maybe someone call it YUV, or YCBCR is almost the same. The CBCR describes how the color looks like the CB means how look like the blue, and the CR means how look like the red, something like that. So whether we can use HSV or YCBCR is depend on the method you choose to segment the color. Something is also important if we concern about the image format from the camera. For example, if the camera capture the image use a YUV format, so you use YUV or YCBCR method to segment the color is more easily because it did not need to change all the value from the YCBCR to HSV or RGB. So this three color space can change use formula between each other. So many of the color segment method is use HSV or YUV. In the OpenCV apps, the camp shift use YUV color space to segment the color. So that's why we can find in the demo. Okay, and I can also show you another method to in the OpenCV apps to get another very interesting result. For example, I use another one. Edge detect. Let me stop here and we can run again. Image. I have the wrong name of the topic. We can find the edge. Can you find out the edge of the object on the table? It's almost a perfect edge according to the color. According to the edge detection method, almost a perfect edge. Okay. Okay, Jeffrey, thank you.
All right, thank you, David. So okay, let's we can find this and it is very interesting. But we don't stop here. Although okay, so you're very happy. Let's say, for example, this is a very nice computer science image processing example. But let me show you further from here. We are not going to run away from CamShift yet. I want to show you what we can do with this CamShift example, because this example is taken from OpenCV apps. But what, as a robot developer, what we can use, we can leverage without even changing any of this code, we can actually develop something meaningful for our service robot. So let me show you how to do it. So David, can you show us? So I need collaboration with David now. So we'll do it at the same time. So David, can you show us the CamShift source code? Okay, so this is where you can find the source code. Okay, so first thing is you head to the into our workspace.
OpenCV.
Right.
Yeah, OpenCV apps.
Apps, yes, correct.
And
then inside there you okay. So this time, because we are not using the script, because it's not a Python, so sad to say that this example is all written in C++. So inside the source, you can find this nodelets folder where you can find all the source code of the example that you just see. Okay. So first, if you open up this camshift nodelet.cpp, okay, so that is the source code of the example just now. It is quite complicated, it's quite long, but inside here have all the information that you need. I'm not going to tell you, I'm not going to ask you to straight away jump into this code and try to modify it from there in order to do your application. In fact, you don't need to do any changes to this code. But what I want you to see is try to have a look on this code in order to understand what kind of result this example actually provide you. Because the result is something that you can leverage it to develop your robot application. So inside here, you can see a lot, but of course, like if you're not familiar with C++, it might be a bit difficult. But over here, I show you one example, okay, to demonstrate my idea. So now, for example, I want to track this particular object with a certain color. Okay, so just now you see there is a circle that will track that particular object. So my concern is, can we actually get the coordinate of this circle in order for me to track or do some tracking for my application? So inside here, maybe you can search, like, for example, X, Y position or things like that. I'm not sure if you can find, but okay, so maybe you have no idea. You look at it and you have no idea. So maybe another clue that you can do is you open up your terminal and you see what are the topic that is generated but after you run the CamShift application. Right. So okay, so David now run the application. Then you try to have a look what kind of ROS topic that are generated.
ROS, restart the let me check. Okay, and we restart the bring up of the camera and restart the method of CamShift.
Okay.
CamShift, something wrong?
Something wrong with CamShift?
Yeah, we restart again. CamShift.
Image raw, not ray.
Oh.
Okay.
And
okay.
I will select, for example, the green one here.
Okay.
Okay.
Right. So now you open a terminal and you look at the all the topic generated list. Okay, so these are all the topics that generated by CamShift and something you can use, right? So can you see, like, okay, right. So over here, everything looks okay, but I think something look interesting is this track box. So track box to me maybe sound like it's the box that tracks something. Okay, so in order to further investigate, I try to bring out what are the messages. So ROS topic, echo, and we print out that particular track box. Okay, so you can see it is actually a structure that give you like all the frame, and then in all the frame, the important messages. Okay, over here, I think something very interesting is the XY value, the center. So I guess this XY value is the center of the track area. So let's examine if this is correct. So David can show us like the one, and you try to move the green color triangle and see if, okay, please look closely the changes in X and Y. You can see if we move horizontally, the X value change, the Y value don't really change. If we move it horizontally, which is in real world is actually front and back, the Y actually change, right? Okay, and then the OpenCV, or in this case, the origin of the XY maybe is the top left, which is different from a Cartesian, but that is the convention in OpenCV or in ROS. Okay, so we are quite sure that this XY value is the center of this circle. Okay, so what we can do with this is actually very convenient. Why? Because in ROS, if once this is in topic, so what we can do is we can write another node, which is our application node, subscribe to this topic, okay, which is the cam shift track box, and then if you remember our subscription, so we will get the callback, and then we will have the value of the data. So you data.wax and data.y. Basically, you can straight away get this XY value in your application. So with that, you can do a lot of things. For example, if you want to do the color tracking robots, for example, you have a two wheel that you can track this object. So you have a camera, you track this, and you can measure when the XY value change. For example, like when it change in terms of X, so you know the object go to the left or go to the right. And if it change in Y, then you can know that it is become further from you or nearer to you, because that object won't become bigger and smaller. So the only possible is it go further and it come nearer to you. So that change in terms of vertical way or lateral way. Okay. So with that, we can actually create our robot application and leverage this example. And you can do a lot similar thing with other example. For example, you can do the same thing with face recognition, because the result will also show you something about where is the face, the center of the face, and how is it. So with that particular tracking result, you can do a lot of application. So let me show you the application later. For example, I'll tell you more about this application after this. So now you get the idea how we can leverage this example without changing this example, and we can start develop our application. Okay, so I hope you get the idea, because this will be going to be the assignment for today. Right, but never mind. Let's proceed to the next example. David, go to the face recognition. Okay, so the next thing is I'm going to show you more example, but the concept is very similar. Okay, is how to use the example in this OpenCV apps, and then we leverage the result provided by this example. So I'll show you three examples that look very similar in face recognition application that you can use it. Okay, later on, I will show you a scenario how we can use this. Okay, so first, you bring up the same thing. So you start your camera, then you need to like make sure that your topic is correct, which is over here is a USB cam image raw is a topic. Then I will introduce you three examples. Okay, three examples. The first one is face detection using cascaded classifier. Then the second one is face recognition. Then the third one is people detection. So first, let us understand what are the differences between face detection and face recognition. So the first thing is face detection is in a frame or in an image, how many faces appear. Okay, regardless whether you know the faces before or not, right? Regardless of whether you know that person or not. So face detection is to detect how many faces appear, human face, okay, human face appear in the particular image. Then once you have this, all these faces detected, you can do recognition. Recognition is where you recognize this face belongs to this person. This face belongs to another person. Okay, so that is recognition. Okay. Then the third one is instead of the face, because sometimes you don't see the face, especially in public place where your robot need to find someone. Sometimes you can see half, and even like if the person is facing behind, so you can't really see the face, so we cannot detect the person. So we have another way, which is the example over here is we use the people detection. People detection is instead of using face, it use the body features. For example, the limbs, the arm, the legs, and so on. So you need to make sure that the whole person appear in the frame in order to get the detection, right? So later on, David will show you this tree, how we can make this tree, and then at the end, I will show you so what we can do with this example. Okay, David, please show the demonstration.
Okay, now for we want to show the result of the face detection. I need to change the camera from the USB camera to the notebook camera. So I just change the unmount the USB Logitech web camera and mount the Xiaomi USB camera. So I use the same command to bring up the camera. Okay, that's me. Thank you. And then I will run the face detection. Face the OPP. Oh, sorry, the package name. We also need to tell the node where the image come from. The node will start another window, so we can find the there is a purple circle around my face, and there is also a two blue circle to show the where the eyes is. So if I remove the glass, maybe that will be also another circle, blue circle, to show me where the mouse is. So this is the result of the face detection. Because the robot, the computer, program don't know who I am. So this is only just to detect where there is a face in the. So it can detect two face here. Okay. Oh, okay. I will show you the face recognition here. So if we need to the robot to know who am I need to tell them, or just at least teach them who am I. So this is the second sample, face recognition. Okay. It will also open several windows. The first is the face detection window here, and there is also something like a terminal to ask me, please input the name and press enter. So I will input my name. There we here, and we will double check whether the name is okay. Yes, of course. And then please stand at the center of the camera and press enter. So this will begin to get some sample to train the robot to know who am I. The first, yes. Another one, yes. Yes. So we can change the position of our face to get more different view of the face, and this will help the robot to know the person more exactly. Okay, I think it's enough. And no. So there is a face recognition debug image window. We can see the result of the face recognition. There is a right here, and that is my name, David. And this number may be the 置信度怎么说
Confidence level.
Confidence level. Yes, confidence level here. So this is a result of the face recognition. So the robot can know who am I. It also can input another name. If there is another one, we can also input another name, and we just capture some image from of another name to get another recognition result here. So okay, I will tell you where the image is stored for if you want to remove all the recognition result, you can find here. So this is the home position photo, and we can press. This is a hidden image and hidden files and folders. We use Control and H key. Control and H key. We can find more folders and files here. This is a invisible file and folders. We can find at the point rows and OpenCV apps face state. So we can find the name of my name folder, and if I open the folder, we can find the sample image here, all the sample image. The program just keeps the area of my face, not the full image here. Okay, if I delete here, delete the folder, okay, move to trash. The robot need to retraining again, something like that. Okay, this is face recognition, and the last one is the people detect. People detect. Okay, I will turn to my another camera, USB camera. Okay. 手拿，哎。US，哎，断了吗？没找到这个摄像头。嗯。Okay, here. Double check. Okay, here. Okay, I will start another. People. Image. You can find the people detector window shows the result of people detection. The glass reflection will affect the result of the detection. So could you please come close? Okay. 再近一点，再近一点。Okay. We need to make sure the image can capture the height and the foot of the person. So if we too close, 再离近一点。Yes, if we too close, for example, we can capture the foot of the person. Maybe there is something wrong with the detection result. Jeffrey, that is the result of the demo. Thank you.
Right. Thank you, David, and thank you, Wu, as well, for the demonstration. Right. So let's come to the summary. So I'll show you like, so once you got all these things, so what you can do. David, maybe we'll skip through this because like they don't have the depth sensor, but maybe this example, I think like everyone have seen this example, which is just now all the application are about the images, right? But in RGB sensor, we have the depth information, that we have the point cloud information. So we can do a lot more application with that. But since you don't have this equipment in your house, so we don't really go long for this. But just to demonstrate the concept is over here. I'm sure everyone have seen the videos that the robot actually track my leg and move around. And then how the tracking is done is based on, we actually try to capture the point cloud, which is the point that reflected back uh, once the infrared ray actually hit the object in front of the robots. Okay, so we will get the point cloud data, something similar like just now you have seen in our race. And what we do is like we do some analysis on this data. For example, in this example, we want to ask the robot to track the person in front. So the person in front has some volume, right? So which means it will generate a point cloud. Okay, so what we do is like we calculate the centroid of this point cloud. So each point will give you the XYZ, right? But over here, we are not really concerned about the vertical value because like we are moving on a flat plane. So what we concern is the lateral and longitudinal changes of the center of the centroid of the object in front. So with all the point cloud, we can calculate with the value of X and with the value of Z. Then from there, we determine okay, over here we use a very simple P control, which is we just put in the gain. So we specify the X and the Z scale, calculate with the error, which is a difference in terms of X and Z. So from there, we can control the wheel in order to track the person in front. So this is one of the very simple example in order to use the point cloud. And the parameters that we can control with the example code given in ROS or in Checkerboard is the size of the box, which means like how sensitive you want it to sense, and also the scale, which is how is the corrective behavior. But of course, you can introduce a PID controller or PD or PI controller and so on. You can improve a lot. And also, there are people that say that this method of detection only able to detect the front object but not able to recognize, which means you will get distracted if you got another person walk across you, or you have other furnitures around that very similar, like for example you have a chair or door or anything that will really like affect the calculation. So there are a lot more that we can do if, let's say, for example, we add in color detection, we add in face detection, or the people detection, and so on, in order to make the detection not just to detect something, but also to recognize the master to follow or particular person to follow. Okay, but that one we will keep it for next time when you have the equipment. Then we will discuss further. But over here, I tell you the basic concept of using the point cloud to do some application. Right. So David, next, let's go to the assignment. Okay. So this is these are the command in order to run the example. Okay, but we will skip this for now. Okay, so let's come to the last part of today's class. So last week we have a speech interaction. So you're able to develop the speech interface for your robots or for your machines to interact with the normal user. So you can give some input, right? And today we learn about the visual perception. So you can make you can add one webcam or whatever cameras that you can attach to your machine, and your system able to get this information and do some processing. So just now show you able to analyze color to do some tracking. And then we also can analyze faces. I mean, we can detect faces. We can recognize even that person belongs to someone if you do the training well. And also we can do the person recognition. So now this assignment is to open to you if, let's say, you can merge these two together and create some interesting application. So I'll give you some example for you to refer, okay? But it's up to you how you want to develop, because that is where you can practice whatever that you have just learned. So one example is just now in the first, in the few slide, the take photo slide, I explained like you can build a automatic or interactive photo taking robots, for example, that. So you can have the machine station somewhere. Then you have people that you want to take a group photo without need to sacrifice someone to hold the camera. So you can have all your friends and you stand in front of the robots. Then you can give using your voice, tell the robot, please take photo or take photo. Then the robot hear and say, do you want me to take photo? Then you say yes. Then the robot will say, okay, stand in front of me. Uh, 3, 2, 1, cheese. Okay, that is the first layer. Not so intelligent because like a robot don't really see whether you are inside the picture or if someone actually outside of the frame or so on. So you can use the face recognition or face detection to actually get the location of the detected face and try to arrange them. So if in case you know the size of the frame, then you know the location, the XY of the faces within the frame, and you can see someone is actually very near to the edge. Then you can say, like, okay, people on the left-hand side, can you please stand to the middle? It is very similar like your cameraman, okay? So you can ask people to stand so that to make sure that all the faces are within the center of the frame. So that is something that you can do. You can even do a lot more, like you can detect like, okay, can I have all the ladies on the left and all the guys on the right, or ladies behind, in front, or guys behind. That is something you can do with just all the tools that we just introduced. Okay, but of course the gender recognition is not discussed today, but you can easily find the gender recognition example in OpenCV. Okay, you can easily find the Python code. I can for sure, you just go in Google, you just search OpenCV gender recognition. You can find a piece of code and you can just put in your workspace and you just run it. All right. So you can get that, and then you can do a lot more, like not just that. And other things is that you can do the tracking. If you have robots, you can able to run the wheel, and then you can track a ball. For example, you have a red color ball, you want the robots to follow the red color ball. You can do that with things that we have as well. And you can add in more because you can incorporate and combine with the speech to make your robot understand some concept, new concept. For example, you can teach the robot about colors, the colors, and even you can teach your robot about names. For example, you can build a receptionist robot, for example, over here. So for example, now we have a hotel, we want to do a receptionist robot. So what we do is like, okay, so when someone comes near the robot detects some faces, which is not recognized, is previously not in database, then the robot will say, okay, good morning or good day, sir. What can I serve you, or what is your name, or do you want to check in or anything? So you can do that. Then the person will say something, okay, I want to check in, or I want to reserve a hotel or a room or anything. Then you can start to like ask like, what is your name? Then you can record the name. While recording the name, you can ask the person to stand in front of the camera to take the photo. So in case, so you can do the training, right? You can all do all these things with speech interaction and combine with your visual perception. And all these things can be done with the tools that we just introduced to you. You just need to do some assembling the node and package together, and also to write some instruction node that behind that will coordinate all this operation. Then once okay you have all the training data done, then okay, so you can say proceed to your room in room number what. And then the next day when the person come in, then you can do the recognition. You have some okay quite high confidence level that this person belongs to this. Then you can say okay, hi, so Mr. something something or Miss something something, and what do you want and how can I help you and so on. So you can do a lot more with the tools that I just showed you, and you can add in other tools. And with this framework also, try not to limit yourself with just things that we introduce to you, because we are introduced you to platform, OpenCV, ROS, and you can actually add in more by yourself. I can share with you like my friends, my student in my class, they actually come up with very nice assignment that they add in a lot of features. For example, they use the face detection module. Then they add in something like they overlay the face with some, we have a lot of apps currently that you can put the face and you can add like the doggy, the cat face, and so on. So they actually did that in the assignment. So they start to appreciate that things that they can do with your phone app, anything that you can do with your phone app, now they can do it, and they know how to develop that thing. And then they can start to put in their creativity and create more interesting application based on all these things. So my students, yeah, they're amazing. They show me very nice assignments. So I hope by showing you how to do all these things and the development platform, I hope you can get this and feedback to us if you have come out some very nice application. Share with us your video or anything that we would love to see all these things. You can upload to GitHub. We can discuss the code with us, and yeah, we can discuss in our group, Facebook group, or you can like email to us, or yeah, you can talk to us also in the next Zoom session and so on. So with that, I would like to close the session. Okay, so we are about 2 hours, just nice for our time. So we start a bit late today. But with that, I would like to conclude. And then, David, do you have anything you want to say?
Nothing. Thank you. Thank you very much.
So today, before I closing, I would like to say thanks a lot for you to attend, and also I appreciate the cooperation from Jupiter Robots. So thanks, David and Wu, to help me for the demonstration. Okay, thank you very much, and please, if you like and you think this session is good, please invite more people and join our class next week so that we can continue doing this class. Okay, and also don't forget to sign up for the competition. So with that, thank you very much, and I will see you next week. Oh yeah, I have a lot more. Okay, I have one more slide. So let me like David, can you go to the slide before? Okay, just to add, today we are showing you very simple application. So it's a very basic, it's nothing advanced. Okay, we have a lot more in image processing, deep learning, post generation, and all these things. And also we have vision-based manipulation and so on. So if let's say you really like this thing and you want to know more, please contact us, feedback to us so that we can arrange more classes after this. And also, yeah, get in touch with us. We have a lot more classes in plan, but we need to know how to provide this to people that interest. Okay, with that, thank you very much. Maybe David, you can show the last slide to show the link where to sign up for the competition and also our schedule and so on. Okay, so done. Right. So this is really, I've said everything. So with that, thank you very much, and we will see you next week.